Hi, everyone. My name is George, and welcome to my talk on gamifying SDKs. In this talk, we'll be talking about the anatomy of an SDK, and we'll be taking a journey through that to create a game. So first, a little bit about me. I work at SDF on the Horizon team. I've been here for about a year and a half. I first got interested in cryptocurrency back in 2014. I was there for the Mt. Gox days of Bitcoin. I remember when it first made headlines, being $1,000 a coin. Even back then, though, it was hard to mine on a personal computer. And so I remember mining Dogecoin because that's all my PC could get away with. And forgot about it for a long time. And then with the recent resurgence and craziness on that coin, decided it was time to dig up that wallet and see what was in there. Spent like 3 days looking through old hard drives, old flash drives, even SD cards, trying to find that private key. Finally found it, and it was worth it in the end. But ultimately, that's the path that got me to where I am today. Like I said, I work on the Horizon team, and I'm also the JavaScript SDK maintainer. So that's enough about me, though. This talk is about SDKs. And here is the agenda for the talk. First things first, we're going to understand what the role of SDKs is on the Stellar network. Then we're going to talk about the structure of an SDK, and then we're actually going to use that understanding to add snippets and functionality to a game I've created specifically for this talk. So mission control, we're going to go right to left here. On the right-hand side, we have the Stellar network, which is a decentralized payment network. It's powered by Stellar Core. It's designed to be efficient, speedy, and compact, and it is maintained by a set of validators that exist across the globe, all acting in a decentralized manner, and they work together to bring consensus to the ledger and vote in network upgrades, things like that. Moving over to the left side, we have the Horizon API, which is a more centralized server, even though it also exists in many places around the world. And it provides a RESTful API layer to the complexities and efficiencies of the Stellar network. It lets you query historical information, which doesn't really exist in the current ledger every time that it gets updated by Stellar Core. It lets you pass along transactions to the network itself, and basically just provides a more developer-friendly way of interfacing with the network that most of us are familiar with. You have HTTP endpoints, and you interact with those instead of interacting with the complexities of a decentralized distributed system. And then one more step to the left is where SDKs live. And that's what the focus of this talk is. We'll dive into the structure of an SDK itself, but essentially it's a language-specific binding that lets you interact with the Horizon network and do things that Stellar Core understands. And one more step to the left is essentially everything that everybody builds on the Stellar network. This includes things like wallets, anchor integrations, and as we'll see in this talk, even games. So recruits of all types are accepted on this mission. We have a lot of language support. As you can see here, there's 9 of them. They're all open source, and many of these are contributed by the community itself. On the left side, we have JavaScript, Go, and Java, which are developed primarily by the SDF, but again, all open source, and user contributions are welcome and encouraged. So a mission debrief then. We are going to be understanding SDKs and their structure first before diving in. And the structure of an SDK is kind of like a pyramid. Every layer builds abstractions upon itself. At the bottom, we have XDR and cryptography abstractions. This is dealing with the actual binary protocol that all of the validators exchange when they are agreeing on ledger content. And we also have the cryptography, which you don't want to be worrying about elliptic curves or what the appropriate key sizes are, things like that, right? You just want to deal with user-friendly addresses. You want to just be able to sign a transaction with your private key. So that's what this layer of abstraction provides, and create key pairs and interact with all of the XDR that is necessary for the network. Transaction memos, claimants to claimable balances, as we'll shortly see, etc. Then at the layer above that, we have building transactions, which are the meat and potatoes, so to speak, of the Stellar network. We have lots of operations that we support, and a transaction is a bundle of operations. So we have transaction builders and operation abstractions that let you put those pieces together, easily sign them with the cryptographic abstractions at the layer below, and as we'll see at the top layer, submit those to the Stellar network. So that brings us to the top, which is querying Horizon and interacting with the Horizon API. And there are a lot of different endpoints that Horizon provides. So you can query current state, which is basically what's in the ledger at this point in time. You can query historical state, which is what happened in the past. So for example, what did an account do in the past to get to its current state and its current balance state, right? And you can also stream historical information, which we'll be doing very, very soon, and get live updates of things as they come in. And finally, and most importantly, I would say, is submit transactions to the Stellar network itself. So you create your transaction from the layer below and you submit it to Horizon, and then it gets taken into the network, and you have actually successfully done something on the Stellar network. So that's the rundown. And now we're going to dive right into mission 1, which is building a base. So we've received an encoded transmission. And obviously this looks like gibberish, but because we're talking about the Stellar network, this is probably base 64 encoded XDR. And now we're going to jump over into a live coding exercise, basically, where we're actually going to try to figure out what this gibberish and mess of letters and numbers actually is. So how are we going to do that? Obviously, when you're actually building an application, you're going to want to you actually know what your XDR is, because you are, in control of everything. But in our case, we're actually just going to try to iterate over everything that our SDK supports. So as you can see, we're using the Python SDK here, and we can literally analyze every single member of the XDR module. And if it has a decoding attribute, so a from XDR attribute, we want to use it. So if it doesn't have one, we want to skip it. And what we're going to do to check the validity of the XDR is we're going to actually try encoding, or we're going to try decoding this secret XDR that we found and re-encode it again to see if it works. And if it works, we're going to add it to a candidate list. So seems like this is viable. And if any exception occurs, we're just going to move on because we don't really care. Now, we want to make sure we actually have a candidate list. And let's see what this spits out for us. All right, it seems like it could either be a fee bump transaction or a transaction envelope. A transaction envelope seems a little likelier because fee bump transactions are typically done during surge pricing, for example, when the fees get too high and you want to rebump things. So let's actually see what's inside this thing. Now we're going to need to encode the network passphrase because things behave differently on the pubnet. And let's see what's inside. So we're going to let's look at the source account. Let's look at the memo that we've got, and maybe all of the operations. Let's pretty print those because there's probably quite a few of them. So what do we got? Oh, whoops. Ah, it looks like there was a bunch of claimable balances, and it was submitted by this account here, GBGB, etc. And there's a memo. It's dangerous to go alone. I wonder what that means. Let's look into these claimable balances, actually. See if we can find something interesting about them. Looks like there's a lot of them, so let's just look at number 4. Oops. So this is the claimable balance operation. Let's look at the amount. Oh, wow, okay. 201 of something. Let's just print it out. Ha, there's a take this asset in here. And of course, it's dangerous to go alone. So there's 201 of them. And looks like there are some claimants. I wonder, claimants. I wonder what that is. Oh, and if you look here, that is actually our account. So this was intended for us. And it looks like there is a time predicate of 14,400 seconds from probably some time ago. So we should probably act fast if we want to claim that. So that's exactly what we're going to do. We're going to be operating at the second layer of the abstraction pyramid that we talked about earlier. First, we figured out a bunch of stuff with some raw XDR. As you can see here, it's literally a bunch of gibberish, and we turned it into something quite meaningful. So now what we're going to do is we're actually going to use the transaction builder abstraction to work with this XDR and see if we can claim some of these claimable balances. So first things first would be to figure out what our account details are. And I actually have placed those into a nice helper library. So we have the player secret. This is layer one of the abstraction network, where we create a key pair from a secret key, and we're going to use that to sign things. But we actually need to load the account first. So we need a server where we connect to the Stellar testnet, and we want to load the account. And now that we have the account, we can actually pass it to the transaction builder. We can set up some basic parameters on the transaction itself. And then we're going to do something very important, which is establish a trust line to this mystery asset, this take this asset that someone has given us. So we're just going to reference it directly. Operations, asset, and hopefully that'll do it. And now we want to essentially claim all of the claimable balances that we can. And for that, we're actually going to have to query Horizon. So Horizon provides us a claimable balances endpoint, and we are the claimant. So let's just claim everything that we can. There are tons of filters to all of the different endpoints that we could use. We could filter by account. We could filter by who the submitter of the claimable balance is. We could look at their operations. Obviously, the SDK covers all of this. Let's not limit ourselves to any defaults. Make sure that we just get everything that we can. And we will finally call this. And the return value from Horizon is actually going to be a dictionaryfied a version of the JSON response, which has these two fields, embedded records. And that's what we're going to look at. So each CB value here now is going to have a claimable balance structure that we can claim. Of course, we don't know that we can claim it because it might be expired for us as a claimant. So what we're going to do is we're actually going to make sure that each of these claimable balances operates at the time that we expect it to. So just like before, it looks like we are the 0th claimant, and there is a time string here. In the XDR itself, it's going to be a relative string, but once we actually get it from Horizon and it's accepted by the Stellar network, it's going to be an absolute string. So it's converted into a UTC timestamp, and we're going to want to make sure that that timestamp is compatible with what we expect. So if the timestamp, the absolute before predicate on this claimant, is later than now, which means we can claim it, let's actually add a claim claimable balance operation. Claim claimable balance for this particular balance ID. And then finally, we can build the transaction. We can sign it with our secret key, and we can submit it to Horizon. So as you can see, all 3 layers of the pyramid here are all working in tandem. So first we figured out what the XDR contained. We looked at the details. Then we used a secret key, loaded that, using a cryptography abstraction. We used the transaction builder abstraction to add some different operations to it. We queried Horizon, looking at all of the records available to us for our claimable balance query. And then we parsed out some of the JSON details there, and we added claims to the transaction, signed it, and finally submitted it to Horizon. So let's see if this actually works. Got a breakpoint there. Keep errors no attribute account ID. Of course, because we actually need to use the public key. Let's see. line 33. Doesn't sound right. Let's try that again. Line 41. Ah, yes, there it is. So we could have also used account.account ID, because an account is represented by a public key, and obviously the key pair itself is represented by a public key. So it looks like everything went well. We submitted the transaction. Probably should have saved the response, but that's all right. So yeah, as we can see here, the transaction envelope had some claimable balances in it. We looked into those. We saw that we were able to claim them. And we have this chunk of code, which looks very similar to what we have here. And as it says here, our munitions pile actually gets a little fuller. And that moves us into mission 2, which is defend your castle. So Intel has told us that there's an incoming bombing run, and that's why this transaction memo led us in the right direction. It's dangerous to go alone. And the enemy is actually using their novel stealth technology to hide their bombs that they're sending towards us by encoding their position and damage into payments on the Stellar network. So without figuring out where their payments are coming from, we actually can't see any bombs coming in. So this is the game. We got some ammo here, we got base health, and there are no bombs because they are secretly encoded into payments. So let's throw up a background thread that'll watch for payments from the enemy's account. We're going to cache the latest payment so that we don't get any outdated information, and then set up a stream for new events. So that's going to be over here. We want the last transaction. And to do that, we are once again going to query Horizon. So there is going to be a transactions endpoint, and it's going to be for a particular account. And it's going to be the latest one. So we just want one, and we want to order it in descending order so that we get the latest. And then we're going to call it. And as before, the response had an embedded field and a records field, which actually contains the record. And what we want is the paging token, which is a unique token for every transaction that you can use to page from one page to the next into a variable, so that we always start at least from here when we run the game. And now we're going to set up the actual background thread. Once again, we are going to want to find all the transactions, and this payment handler actually needs transactions and operations, because as we saw, the operations have the bombs in them, and the transaction contains the position and damage that it's going to apply to us. Well, the damage is actually the amount on the payment value. So let's make a builder and look at all the transactions once again, except this time we're going to be using a streaming endpoint. So we need to set up a cursor from the last transaction. And for every transaction in the stream, we're actually going to also need to look at the operations for that particular transaction. And again, we look at the embedded records for that. And for every, for opt-in records, we're just going to pass that along to the handler. Let's see, does everything look right? Oh, there's one detail that we're missing. We only care about payments. So if the type of the operation is a payment, we care. Otherwise, we don't care about this particular operation. There's going to be things like account creation, and we actually have no idea because we don't control this account. So we want to make sure that we handle it correctly. Let's see, I think we can just pass the account here instead of the address. And let's see if that worked. So let's see if any bombs come our way. Uh-oh, there's one over there. I'm gonna have to shoot it down. Uh-oh. Uh-oh. Oh, we took some damage on our base. Oh man. Here come the bombs. Well, they're all coming down the left side. Looks like somebody left a bug in their position encoding code. Well, they're all going to be coming from the left side. And as you can see, our ammo is decreasing, and the ammo is actually pulled from the Horizon server as the balance of the asset that we just claimed in the claimable balance. So that is exactly the take this asset. It's being queried from Horizon and represented here. And it looks like we're actually going to run out of ammo and not defend our base successfully. Because, well, actually, thanks to a bug in the code, I can keep shooting. This is what happens when you don't check your win conditions properly. But good thing for us, we can go into debt, go into ammo debt, let's say, and actually defend our base. Let's see how many of these we can take down. Our base is getting pretty low. Oh no, only one more. I think we might lose. Oh, this is bad. Oh, looks like we won. Thanks to 2,576 ammo in debt. Hopefully our lovely sponsor that sent us the take this asset will pay back that loan. I'm not sure where we got it from, but thanks to being a finance network, I'm sure we could have done something with that. So yeah, our base was taking damage, and we decoded the payment locations from the stream, and the mission was accomplished. Like I said, we went into some pretty deep debt, but things worked out anyway. So just to recap, these were the three elements of an SDK that we use. We combined them all together. We have the cryptography and XDR abstractions. We had building transactions, using those abstractions, signing them, making sure that the right accounts are there, sequence numbers are updated. All of that kind of happens transparently in the SDK, and you just have to use the abstractions. And finally, querying and talking to Horizon, streaming payments, looking at past history, transactions, claimable balances, as we saw, and finally, submitting payments, submitting transactions so that we could claim those balances. Yeah, so with these three abstractions, you can put the pieces together to do pretty much whatever you want. It doesn't actually have to be finance related, as you saw here. You can turn it into a game where the payment stream is actually a stream of bombs coming towards your base. So thank you. That's the end of my talk. Hopefully that inspired you, and you should go forth and build something in the language of your choice, because we support a lot of them. There's a comment section down below. Feel free to comment on whatever it is you're going to be building next. Thanks so much.